Welcome to the Fox Learn. The interface defines the methods that a class must implement, but it doesn't dictate how the class implements these required methods. This provides a lot of flexibility on the part of the class designer, yet it allows client classes to use those methods with confidence, because the interface methods are guaranteed to be implemented. There are a lot of interesting things you can do with interfaces, including implementing multiple interfaces, combining them, inheriting them, and casting to them. An interface is a contract. When you design an interface, you're saying, if you want to provide this capability, you must implement these methods, provide these properties and indexers, and support these events. The implementer of the interface agrees to the contract and implements the required elements. The syntax for defining an interface is very similar to the syntax for defining a class. Access modifiers, public, private, and so forth, work just as they do with classes. The interface keyword is followed by an identifier, the interface name. The class implementing the interface must fulfill the contract exactly and completely. Thus, your document class must provide both a read and a write method and the status property. Classes can derive from only one class, and if it doesn't explicitly derive from a class, it implicitly derives from object. When you design your class, you can choose not to implement any interfaces, you can implement a single interface, or you can implement more than one. For example, in addition to Storable, you might have a second interface, compressible, for files that can be compressed to save disk space. You can access the members of an interface through an object of any class that implements the interface. For example, because document implements Storable, you can access the Storable methods and property through any document instance. You can, however, create an instance of the implementing class and then assign that object to a reference to any of the interfaces it implements. The as operator is similar to is, but it goes a step further. The as operator tries to cast the object to the type, and if an exception would be thrown, it instead returns null. You can extend an existing interface to add new methods or members. For example, you might extend iCompressible with a new interface, iLoggedCompressible, which extends the original interface with methods to keep track of the bytes saved. You can also create new interfaces by combining existing interfaces and optionally adding new methods or properties. For example, you might decide to combine the definitions of Storable and iCompressible into a new interface called StorableCompressible. This interface would combine the methods of each of the other two interfaces, but would also add a new method, logOriginalSize, to store the original size of the precompressed item. When you create an implementing class, you're free to mark any or all of the methods from the interface as virtual. Derived classes can then override or provide new implementations, just as they might with any other virtual instance method. For example, a document class might implement the Storable interface and mark its read and write methods as virtual. In an earlier example, we created a base class note and a derived class document. While the note class implements read and write to save to a file, the document class might implement read and write to read from and write to a database. In the implementation shown so far, the class that implements the interface document creates a member method with the same signature and return type as the method detailed in the interface. It is not necessary to explicitly state that document is implementing Storable. For example, the compiler understands this implicitly. What happens, however, if the class implements two interfaces, each of which has a method with the same signature? This might happen if the class implements interfaces defined by two different organizations or even two different programmers. The next example creates two interfaces, Storable and italk. Italk implements a read method that reads a book aloud. Unfortunately, this conflicts with the read method in Storable. Because both Storable and italk have a read method, the implementing document class must use explicit implementation for at least one of the methods. With explicit implementation, the implementing class document explicitly identifies the interface for the method. Marking the read method as a member of the italk interface resolves the conflict between the identical read methods. An interface is a contract through which a class guarantees that it will implement certain methods, provide certain properties and indexers, and support certain events, all of which are specified in the interface definition. You cannot create an instance of an interface. To access the interface methods, you need to create an instance of a class that implements that interface. You declare an interface much like you would a class, but using the keyword interface. You can apply access modifiers to the interface, as you would with a class. In the interface definition, the method declarations cannot have access modifiers. To implement an interface on a class, you use the colon operator, followed by the name of the interface, similar to the syntax for inheritance. Classes can derive from no more than one class, but can implement any number of interfaces. If a class has a base class and one or more interfaces, the base class must be listed first, after the colon. Separate the base class and interface names by commas. When you define a class that implements an interface, you must then implement all the required members of that interface. In situations where you don't know what type of object you have, and you know only that the object implements a specific interface, you can create a reference to the interface and assign the object to that reference, providing you with access to the implemented interface methods. You can use the is operator to determine whether an object derives from a base class or implements an interface. The is operator returns a Boolean value indicating whether the cast is valid, but it does not perform the cast. The as operator attempts to cast a reference to a base type or an interface, and returns null if the cast is not valid. You can extend an interface to add new methods or members. In the new interface definition, use the colon operator followed by the name of the original interface. This is very similar to derivation in classes. The extended interface subsumes the original interface, so any class that implements the extended interface must also implement the original interface as well. A class that implements an interface may mark any of the interface methods as virtual. These methods may then be overridden by derived classes. When a class implements two or more interfaces with methods that have the same name, you resolve the conflict by prefixing the method name with the name of the interface and the dot operator, for example, Storable.write. If you do this, you cannot specify an access modifier, as the method is implicitly public. Let's start in the middle, where we declare the interface. As you can see, the only difference from a class declaration is the keyword used, interface instead of class. Also, the name of the interface is prefixed with an I for interface. This is simply a coding standard, and not a requirement. You can call your interfaces whatever you want, but since they are used like classes so much that you might have a hard time telling the difference in some parts of your code. Then we declare the describe method, and afterwards, the name property, which has both a get and a set keyword, making this a read and writable property. You will also notice the lack of access modifiers, public, private, protected, etc., and that's because they are not allowed in an interface, they are all public by default. Next up is our dog class. Notice how it looks just like inheriting from another class, with the colon between the class name and the class/interface being subclass/implemented. However, in this case, two interfaces are implemented for the same class, simply separated by a comma. You can implement as many interfaces as you want to, but in this case we only implement two, our own iAnimal interface, and the .NET iComparable interface, which is a shared interface for classes that can be sorted. Now as you can see, we have implemented both the method and the property from the iAnimal interface, as well as a compare to method from the iComparable interface. Now you might be thinking, if we have to do all the work ourselves, by implementing the entire methods and properties, why even bother? And a very good example of why it's worth your time, is given in the top of our example. Here, we add a bunch of dog objects to a list, and then we sort the list. And how does the list know how to sort dogs? Because our dog class has a compare2 method that can tell how to compare two dogs. And how does the list know that our dog object can do just that, and which method to call to get the dogs compared? Because we told it so, by implementing an interface that promises a compare2 method. This is the real beauty of interfaces. Interface 2 inherits interface 1. When one interface inherits another, any implementing class or struct must implement every interface member in the entire inheritance chain. Since the simple interface class inherits from interface 2, it also inherits interface 1. Therefore, the simple interface class must implement the method 2, specified in the interface 2, and the method 1, specified in the interface 1. When an interface method is mapped onto a virtual method in a class, it is possible for derived classes to override the virtual method and alter the implementation of the interface. Thank you for watching this video.